Have you ever watched perspective videos that end up with something looking like this, but then when you go to draw, wondering how on earth that applies, if at all, to the scenes in front of you, and how can it help you, or what do you need to do because of this if you're drawing this? In this video, we're going to look at a number of real-life scenes, and I'm going to identify the key perspective information that we normally see in little schematic diagrams like this, but show you how they do or don't apply in real-life scenes that we go to draw, and even how they apply or don't apply in scenes where we might not even think of them having any direct application. Let's start with this scene of the Amsterdam Central Railway Station. We've taken one perspective angle up here on this tower going off to the side and one lower down, and they meet over here. So let's take two angles that go the other direction and see where they meet. And they meet just off camera to the left. And so now we know that eye level should join these two spots up. And my new U-Butte longer eye level line isn't actually long enough to do that, but it would sit something like this. And you might ask, why is it sloping upwards from right to left? Shouldn't eye level be straight? And yes, it is. It was the camera that was sloping when the photo was taken. If we look at other lines, other angles from other parts of the building, we can see that the ones sloping down to the right also end up meeting at the same place, or would if they were long enough. Similarly, all the perspective angles here meet at the right place. So this is a fairly straightforward example that fairly easily follows this pattern. The only thing it shows us is that we need to be aware when we're working from a photo that either the camera may not have been held square on when the photo was taken, or when the photo was taken, this is in the center, and this was actually a vertical line, but that the photo was then tilted to make this the vertical line for aesthetic reasons. Or the photo may have been cropped. So we need to be aware when we look at a photo that the eye level is not necessarily going to appear straight across our scene. But if it tilts, all the perspective angles will still meet at the same place on this line. So let's look at a more complicated possibility. Here we have some houses in the village of Whitby in England. And for this building in the foreground here, we can see that the perspective angles of the roof lead to over here. So let's get another angle that angles the other way if we can. Stone courses often provide a very useful way of identifying perspective angles. And so looking at this, we can see that the horizontal line is going to be, it's sloping down there, it's sloping up there. It's going to be about here, in between these two courses. But what do we make of all these other perspective angles? How can this relate to this jumble? Well, let's look at the angles of these buildings up here. When we go down like this, we actually find that they don't meet at the same point as these ones. They actually meet further along. So let's get another angle. Now, unfortunately, most of this building is hidden by this building. So possibly the most reliable spot is the middle of these two windows. Is that in fact, while they don't meet in the same places down here, they do meet on the same line, on the eye level. And we know that all vanishing points meet on eye level, so that's right. But aren't all of these angles meant to meet at the same point? And the answer is only if the buildings are parallel to each other. And this row of buildings behind this one actually slope at a different angle to this building. This row of buildings and this building aren't like this, but they're like this. And that changes the perspective rules and says the vanishing point for these buildings will be in a different place. We get the same thing if we look at the vanishing points for lines going in the other direction. I'll just remove these. I could put the vanishing point back in place because I know it's where we've got the horizontal line. And if we take this window, we can see that the lines meet on our eye level around here. And if we look at this line at the top of the roof, we can see that it also crosses in the same place. But what about this building here? Where will these lines go to? If we look at this window, we can see that the lines do cross on the eye level, but again it's a different point. And that's because this building and this building are aligned not at 90 degrees or parallel to each other. And therefore, they have different vanishing points, just as this building and this row of buildings had different vanishing points the other way. So this shows us that for a given scene, we can have many vanishing points, but they will all meet on the same eye level, because eye level stays the same for the entire scene. So let's look at some more houses, but from a very different angle. So here's the beautiful German village of Lemgo. Now, how do we apply what we learn here to something that looks as different as this? Well, let's look to see where some of our perspective angles join. And we need to make sure that we join up lines that are parallel to each other in real life. And so in this square here, this building and this building are parallel to each other. So I'm going to draw the line that their roofs make. And they meet just slightly off camera. Let me get the point where some perspective angles meet going the other direction. And we see that they meet up here. So can we join these with our eye level line? Now eye level is almost straight here, so the camera is not very tilted, or the photo hasn't been rotated very much. The first thing to notice is that eye level doesn't have to be actually in our scene at all. And this happens when we're at some height looking down. And so we're actually pointing our eyes, or in this case the camera, downwards so that it's lower than what we'd be looking at if we were looking straight ahead. So in this scene, if I'd had the camera pointing straight ahead, then this would have been running through our picture. So let's get the perspective angles, say, of this row of buildings up here if we can. And what we can see is that they're not going to meet at the same place that these two lines meet. But they do look as though they will meet on this line, but further to the left. So why aren't these ones going to the same vanishing point as these ones? Because they look parallel. And the answer is because they're not parallel. That this row of buildings and this row of buildings are not parallel to each other. This row of buildings, and if we look carefully we can see it more easily, slopes in towards us more as it goes further along. And so while it looks as though the rules don't apply, in that they don't meet at the same point, it's just that we're applying the rules wrong. We're assuming that buildings are at right angles and streets are parallel when they're not. And unfortunately, many of these videos don't make clear that these rules only apply the way they're presented, with everything going back to the same vanishing points, when the buildings all line up parallel or at right angles to each other. So this scene does actually conform to our rules. So let's look at another more 20th century example. So here we have my hometown, Sydney, and we can see the top of the Sydney Harbour Bridge here and the top of the Sydney Opera House here in the harbour stretching across the upper portion. So let's put a few perspective angles in and see where they go. So if we take two of the lines on the side of this building here, then they meet about here. If we take two of the lines from the side of this building up here, they meet here. They're not at the same point because these streets are not parallel, and because I know Sydney, I know they're not parallel. I'm not sure really any streets in Sydney are. And there's another set of lines we can take as well. This building here, now we could use this angle, and then we could use the angle on the far side, but we don't really see very much of it. But we do get a sense that they really are going to join up on the same place. And we could do it with these lines here, with this one and with this one. And again, it's going to be way off the paper, but we can get a sense that they will meet on this line much further to the left. The easiest lines to use are this one here, the two sides that we really don't see, and this one here, and we can see that they do meet on the same eye level. So again, we have multiple vanishing points for really every building we check, but in fact the parallel lines of the various buildings do all meet for each building in one vanishing point. And where we have a row of buildings that are parallel to each other, such as this row here, they would all meet in the one point. What about going off to the other direction? Well, if we look at this building here and take this line, we can see that it's going to go right off the page to the right. And if we take the line under it, then clearly it's going to do the same thing. But again, we get a sense that these two lines will meet much further off, probably at least 30 centimeters off to the right, but on our eye level. So we can see that the perspective angles going off in each direction do all meet on eye level. And in fact, if we look at the floors of our tower here, we can again see that they meet on eye level. And so every one of these lines, every one of these floors is an angle that fans out slightly as we go from the top floor down to the bottom floor in what is Australia's tallest office block still, I think. But I'm in the Sydney Tower, which is even higher. The other thing I want you to notice in this scene is that eye level here is against the sky. Notice that it doesn't actually sit on the horizon here, and that's why I never use the term horizon, as lots of videos do, for the eye level, because the horizon is something else quite apart from perspective videos. It's the line where the earth meets the sky. But that's not always the eye level or the horizon in perspective, and I think it's misleading to use the same word for this line and this line in the same scene. The next example we're going to look at is the sort of scene that I think gives the biggest problems in drawings I see that involve wrong perspective. So let's clear away this view of Sydney and we'll have a glimpse of 19th century Sydney. Here we have a piece of charming 19th century architecture in Sydney. So let's establish eye level by getting two of our vanishing points this way and two this way. So here we have perspective angles going off in different directions, meeting on eye level. And if we look at further lines, such as this one up here, we can see that it's going to meet in the same place as well. And the same with these angles up here, if I had more longer strips of cardboard. So what is it I want to point out here? I want to point out this line, because this is the line that I see causes so much trouble in people's drawings. This line here. And it causes trouble because what I usually see happen is that I have a line such as this at the top of the building, maybe it would have been this line in this case, and this becomes the bottom line of the building, and then this becomes the vanishing point, and all of these lines angle into here, not to here. So why is this line coming this way and not meeting here? Why is it crossing much further across here? And the reason is because the ground is not flat. All of this is totally dependent on the ground being 180 degrees flat and level under the building to the eye level or horizon point, and that the person viewing this or the level of the camera is also standing on that same level ground. So this ground is sloping. So this is going to obey totally different rules. And taking this photo, I am not on level ground. I am not level with the subject of this photo. The ground slopes up, I'm further back and I'm zoomed slightly, so I'm further away than it looks. And that's why eye level here is this yellow line. My eye level is not level with the eyes of the person we can see in the photo. My eye level is down here because the ground I'm standing on is lower than the ground she is standing on. And if you're interested in how we draw this, I do have a video on drawing uphill perspective, which looks at how we draw buildings when the ground goes up. I also have one on drawing downhill perspective, and I have another one on drawing perspective when the street curves around. But I'll link drawing uphill perspective to this video because I think that's the situation that causes the most problem and confusion in drawings that I see. Our next scene is very different from all of these. Our next example doesn't actually apply to this sort of perspective theory, but more this sort of perspective theory. The theory that tells us that when we're looking at circles side on at eye level, they appear to be in a straight line. We see them actually edge on. And if we were to have a series of circular segments stacked on each other to form a column, and we could see the gaps where the column segments join, then what we'd see is this curve, as the joins move further away from us, become rounded and more rounded and more rounded and more rounded. And if we had X-ray eyes, we could in fact see that the ellipses that are formed become rounder and rounder. So how does this play out in life? So here is a statue in Germany, a very big statue. These are people's heads on the observation deck. But there are a series of lines that if we move far away enough and look side on would all be parallel and horizontal. This line as part of the base and this line as part of the base. And what we can see is that this line here is almost straight. And as these lines that would be parallel if we were far away enough back move upwards, they actually become rounder. Now that's obvious here, but in a structure such as this, the way we can help to visualize the way this working is I can see this line and this line and this line and that line and this line as all forming part of a horizontal line, because these lines would all be lined up horizontally if we were looking straight on. And so these give us an ellipse, or part of an ellipse. And we can see that this ellipse is actually more rounded than this. Now, if we were to count 10 stones up and do the same thing, now again, we can see that this line is a fuller curve than this one here. So let's get these points up here. And again, we can see that our curve is becoming fuller the higher we go. We could take the end of these drainage points. And again, this is a fuller curve than any of these. And if we keep moving up, we can actually see there's a curve here which forms a ledge for the crowds to look on. And that's rounder again. And if we go up here, we get a curve that's much rounder than any of these curves. And up the top here, we have the roundest curve of all. And then we have what the locals call Hermann the German on top. And so when we see these sorts of perspective teaching diagrams, this is how it can look. And if we can find details in our column or tower and recognize that when they're at the same horizontal level, from views where we're looking up or down, the curves that are formed when we align these horizontal elements, as they move up or down, the curved lines will become rounder. Why is there no horizontal line here? And it's because, of course, I was tilting the camera up. So the camera wasn't looking straight ahead and including eye level in the scene. And now we'll have a look at this scene. And what has this got to do with this? And I include this simply to make the point that perspective applies to every single object that we're viewing all the time. Because every object looks slightly different according to the angle we're looking at it from. The perspective changes, the viewpoint changes. So where can we work out perspective angles with this? I'll show you. So with this children's playground, I think somewhere in Yorkshire, we do have this bench which does give me some perspective angles that come off in this direction. Now I'm struggling a bit to find two parallel lines that I'm confident are parallel, because I don't think this pathway is actually strictly of even width the whole way along. So I'm going to use these swings. So I've used these two lines to join here and to put eye level across here. If I align the seat, this seat, I get a line that comes up here that could be joining around the same place. If I use the top of the swing as a line, it's not going to meet. It's actually going to scoot past under our eye level. In fact, it's starting to go down the opposite direction. So why is that? How could a line under eye level not be going up to the eye level? And the answer is because this swing is tilting very slightly to the left. Perhaps more adults than children have been favouring this left-hand swing. And so our pole supporting the swings has a bit of a lean towards the left. So this line doesn't actually align with the others. But with eye level here, one thing we can look at is this house here. And look, while it's obviously at this scale and with these thick lines approximate, if we line up the angles, the angle of the lower part of the house here, and if we then look at the angle of the roof, we can see in fact that they do meet on eye level, because eye level is the same for everything that's in the scene. It doesn't matter whether it's a park bench that's close up, or it's a building this far away in the distance, or in fact even these cottages much further. If we could be confident of these angles and make sure we had eye level in the right place, and use a ruler and a pen, in all of the lines of these houses that are actually hidden by my eye level line would all meet on the very center of this yellow line. And I just realized that with this seesaw we actually can get two perspective lines that do also meet on the same eye level. Now if we were drawing this scene, we probably wouldn't feel the same need to be checking all our eye level perspective angles as we might if we were drawing something as architectural as this. But I wanted to show you that this all still works if we understand it the right way and apply it the right way, even in scenes where the buildings aren't particularly important at all. G'day, I'm Stephen Travers. It was nice to use some of my hometown, and it seems a shame to leave you with this very obscured view of the Sydney Opera House, so here's a better view that I'm waiting to use in another video. I hope this has helped understanding of perspective, so that when you see a scene that doesn't obviously look like the perspectives applying, you're able to work out why this is the case and how you can still use it for a more accurate and effective drawing. But hey, whatever you're drawing and however you're drawing it, and whatever perspective you want to use or not use, make sure you have fun. I'll see you next time. Bye.